All right, hello AP Chem students and welcome to topic 3.3, solids, liquids, and gases. So the learning objective here is 3.3.a, represent the differences between solid, liquid, and gas phases using a particulate level model. So let's get into that. So we have done a lot of this already in the curriculum, so we're just going to kind of bring it all together here in a nice tidy little slide, and then we'll look at some animations and call it a day. So the motion of solid particles is limited, and there is no translational movement. They're just vibrating in place. So in other words, they don't move relative to each other. They just stay in fixed positions. Their arrangement can vary, though. They can be highly ordered crystals, like as we saw with ionic solids, or they can be amorphous, like you might see with a molecular solid, where it's more powdery. The spacing is generally tightly packed with not much space in between. They are in contact with each other. They're touching each other. The volume is definite. They cannot be compressed. And that is because of that tight packing. We'll also see that same property with liquids. The shape is also definite. It does not take the shape of the container. Its shape is determined by its own properties. But if you change the container, it will not change. And then a particle diagram might look like this. Notice that the particles are in contact with each other and they are fixed in position relative to each other. With a liquid, you do have continuous movement and collisions, but they're always in contact with each other, at least to some extent. Maybe not all the time, but you do see a lot of contact. Okay, so think about how liquids flow and pour. You can have droplets that break off, so there's not always that constant contact, but you do have the molecules or particles are moving and still staying close to each other. The arrangement is random, but again, maintaining frequent contact with each other. The spacing is closely packed, not as tightly packed as a solid. So we do see more spacing in between the liquid particles. However, the volume is still definite. It cannot be compressed, and that's similar to a solid. For those reasons, the fact that you cannot be compressed, we call both the solid and the liquid the condensed state, which you might remember from the previous topic. The shape of a liquid, though, is indefinite. It does take the shape of the container because does not have that rigidity of the solid. And so this is what a diagram might look like as a liquid. So you notice there is more spacing between the particles and there is not that ordered structure, but there's still quite a lot of contact. Then with gases, we see constant movement with collisions, and the collision frequency depends on the conditions. So sometimes you might only see conditions rarely, but sometimes you'd see them more often. And that really just depends on the temperature, the pressure, and the volume of the system. Then the arrangement is completely random with no order. They are further apart, again, with the spacing depending on the conditions. The volume is indefinite. They can be compressed, okay? That is a mistake on that. Okay, got that fixed. So indefinite, gases can be compressed, okay? And that's an important thing about them. The shape, as you might expect, is also indefinite. It will take the shape of the container. That's also important when you're drawing particle diagrams. If you're given a box, the solid would sit in the bottom, the liquid would spread out to fill the bottom, but would not go all the way to the top. A gas would be filling the entire container. So that's important to note with the particle diagrams. So just wanted to show you this animation from PhET, which is my very favorite. So PhET has got these fantastic simulations. If you haven't seen them before, I highly recommend. So if we go and we look at the states here, you can see this is a solid. And so it allows us to look at particles of the solid. We can see that they are in contact with each other. There is no translational motion, but they are doing that vibrating. Okay, if we heat that up, you can see that as they get more energy, we see them spreading out a bit more. And so this is where we're actually moving into the liquid phase. So I'm just going to go ahead and make it a liquid. So there we go. And so here's your liquid particles. You see, again, more spacing, more movement. They are in contact with each other most of the time, but you do still have this condensed state. And then if we go again, we're going to heat it up, and you can start to see that some of these particles will get energy and they will become gases. There we go. Let's make them all a gas. And bam, you can see it fills the entire container, and they are bouncing off of each other. But compared to what we saw before with the liquid and the solid, there is quite a lot of spacing in between these particles. So if we return back to our presentation here, that is it. So what should you be able to do with this? Well, you should be able to compare the movement and packing of the particles in the different phases, and you should be able to draw or interpret a representation of a substance in the solid, liquid, and gaseous phases, specifically paying attention to that packing and the movement and how it fills the container. And that is it. So pretty short one today, and I'll see you soon for the ideal gas law in topic 3.4.